First up, we start with the Space Launch System launching from Pad 39B at the Kennedy Space Center in Florida. With its sights set on the moon, SLS blasted off at 12:47 a.m. Central on November 16th. You see those 4 RS-25 engines lighting up the Space Coast. You can also see the core stage climb up, as well as one of the 2 solid rocket boosters in this view. And on top of the vehicle is the launch abort system, and of course the Orion spacecraft now behind the moon. This video shows SLS and Orion's climb to orbit from the perspective of a camera on the rocket. It was about an 8.5-minute climb into orbit. You can see the launch pad grow smaller and smaller as the Space Launch System propels Orion into orbit. Following liftoff and the climb to orbit, the translunar injection burn took place. The translunar injection maneuver took place as the upper part of the rocket, officially named the Interim Cryogenic Propulsion Stage, or ICPS, fired one RL-10 engine producing 24,750 pounds of thrust to accelerate the vehicle to more than 22,600 miles per hour, a velocity fast enough to overcome the pull of Earth's gravity and propel Orion out of low Earth orbit to send the spacecraft to the moon. The TLI maneuver precisely targeted a point on the moon that guided Orion close enough to be captured by the moon's gravity. Now, right after that TLI burn, the interim cryogenic propulsion stage separated from Orion, and you do see that here in the video as it drifts further away from the spacecraft. Later that day, we received our first imagery of Earth, as well as completed the first checkout of the Orbital Maneuvering System, or OMS engine. All went smoothly, and that Orbital Maneuvering System engine was used just 17 minutes ago for the return-powered flyby burn, which lasted 3 minutes and 27 seconds. Several days later, on November 21st, Orion performed the outbound-powered flyby burn, also with that orbital maneuvering engine. This is the sister to the return-powered flyby burn. The orbital maneuvering burn sets us up in a trajectory to head out to deep space. The return-powered flyby burn sets us up on a trajectory to return back home. This video shows Orion as it approached the moon for this burn. And as we mentioned in this broadcast several times, Orion has traveled further than any human-rated spacecraft, but in this view here that was taken just shortly before that, you can see an eclipse, the moon traveling in front of the Earth, a view we don't often see here on Earth. And this photo was taken on Flight Day 13, November 28th, when Orion reached its maximum distance from Earth, when it was 268,563 miles away from our home planet. Orion has traveled further than any spacecraft built for humans meant to return back home. And just last week, on December 1st, the distant retrograde departure burn occurred, which placed Orion in a trajectory to exit the distant retrograde orbit and head back toward the moon ahead of today's return-powered flyby, which occurred just 19 minutes 15 seconds ago. In this view here, you can see the solar arrays, gimbal, as well as a Earth in the almost center of your screen there.